Dr. S. Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers, 2013.
Welcome to UGC lecture series on computer science. We are discussing about the virtualization concept in cloud computing. So, in the last episode, we have seen the different components of a computer, having the hardware at the lowest level, then operating system at the next level, and you are having the application at the top level. Now, this diagram shows the abstraction of this system. As we have discussed, we are having higher level of abstraction that hides the details at the lower levels. Now, when we consider this computing machine in the perspective of the OS developer, how to view it? See, we are having the division of this computer by separating software from hardware. See, in case of this hardware, we are having different components. In case of the software, we are having different parts of it. Now, we are having the instruction set architecture which divides the hardware from software. The major division between hardware and the software is obtained by using the instruction set architecture. So, the ISA is dividing the hardware from software. So, this is the perspective of the operating system developer. Next, when you consider the computing machines, you have to consider the perspective of compiler developer. See, when you consider the compiler developer, normally the compiler developer will be developing the compiler and it will be installed over the operating system. So, you are having the interface which separates the actual applications and libraries from the operating system. So, you are having that ABI which is known as application binary interface, and it is separating the software from the operating system. Now, when you consider this ABI, it is the user instruction set architecture plus operating system calls. So, this is known as ABI. So, ABI divides the software applications from the operating system. The next one is the perspective of the computing machine in the application programmer's view. Here we are using API, that is application program interface. Whenever you are having this API, this divides the application programs from the other part of the computers. Normally, APIs are considered to be user instruction set architecture plus library calls. So, when you consider these two, it is known as the actual API. So, we are having the different layers, and in the architectural specification you can consider the different systems interface which is deciding the logical behavior of its invisible resources. As we have considered, we are having the hardware and the ISA is separating the hardware from the software part. ABI is separating the operating system from the application, and the API is actually separating the applications from the other libraries. So, if you know the different layers which are separating the different components of it, it is easier to understand the concept of virtualization. So, it is essential to know the actual interface called ISA, which is separating the hardware from software, ABI which separates the operating system, and the applications API, application programming interface, separating the application from other part of it. Now, the same thing is given in the form of stacked architecture. See, we are having the kernel space. Kernel is the core part of the operating system. Everybody knows about it. So, the kernel space is having different system calls as well as various instructions, that machine level instructions included in it. Then you are having the user space. That user space are having the user level libraries and the various applications. Whenever you develop any application, normally you will be using so many library functions. It is not necessary to write all the functions on your own. Say for example, if you are having an existing sorting algorithm implemented and available in the system as a library function, when you develop an application, just you make use of the existing sorting library function for writing your application. Normally, we are using so many mathematical applications while writing program. Say for example, SQRT. SQRT is the square root function. So, whenever you develop an application, you are using the SQRT function, which is a library function, and that is useful for writing your complete application. So, like that, the applications can be easily developed with the help of so many user level library functions available. So, they are known as APIs, application programming interfaces. So, we are making use of so many API calls which are used by the applications, and they are calling the user level libraries. So, API calls access the user level libraries. Then the user level libraries will in turn make use of so many system calls, so that the kernel of the operating system will interpret the meaning of the system calls, and it passes the information to the hardware, and according to the actual instructions, machine instructions, the hardware will be activated and the operations will be performed. So, you should know the stacked architecture of the machine based on the ISA, based on the ABI, and based on the API. So, this is what we are calling as the machine instructions, then the system calls, which are nothing but the ABIs, then APIs. So, these are the various stacked architectured nature of the machines. When you consider the virtualization, we can see the architecture in this way. See, you are having different servers available in the entire distributed environment. You are having one virtual server. By using different virtualization software such as Zen or OpenVZ or VMware, it is possible to create virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4, so that a single machine is created into 4 virtual machines. Here the different LAN connections are available. You can have the SAN fabric, storage area network, to share the storage also by these computers, and you are having the standby virtual server also. Whenever there is a failure, that standby virtual server is also helping to solve our problem. So, it is possible to create so many virtual machines from one single virtual server. This server is able to create multiple virtual machine. This is the physical server. We name it as virtual server because it is possible to create so many virtual machines, and it is possible to create the virtual machines from virtual server also. That is, you can create 2 big virtual server from one physical server. From that virtual server you can create multiple virtual machines also. So, that is also possible. So, this is the overall view of the virtualization architecture. Now, let us go to the actual definition. What is the actual definition of it? A layer mapping its visible interface and resources onto the interface and resources of the underlying layer or system on which it is implemented. That is what the interfaces such as ISA, ABI and API, that is the actual meaning of it. So, we are mapping the visible interfaces and the resources into the underlying system. What is the purpose, or what are the purposes for that virtualization? The first one is abstraction. Already we have discussed about the abstraction of the computing machines in the perspective of user, compiler developer as well as the OS developer. So, it simplifies the use of the underlying resources by removing the details of the actual physical machine structure. Then second purpose is replication. It is possible to create multiple instances of the resources. Say you can create 3 virtual machines from one single physical machine. That is what we call it as replication. Then third one is isolation. See, even though you are creating 3 virtual machines from one physical machine, all the 3 machines are isolated entities. You do not have the connection between machine 1 and virtual machine 2. It is not necessary to show your virtual machine 1 content to virtual machine 2. If necessary, you can network those things and you can give the permission to access it, but without that each virtual machine is an isolated machine. So, it separates the users which clients make use of the underlying resources. So, isolation is also there. So, abstraction, replication and isolation, these are the purposes of this virtual machine. And we are having virtual machine monitor, VMM. This is the program in charge of virtualization. It is also known as hypervisor. So, you should know the software used for creating virtual machine is known as virtual machine monitor. It is also called as hypervisor. It arbitrates the access to physical resources and it presents a set of virtual device interfaces to each host. And you will be having the guest OS runs until the privileged instructions trap and also the system interrupts, and whenever there is an exception or page faults available, and we can have the explicit call by using VM call or VMM call in the Intel architecture or AMD architecture based machines. So, we are introducing the different terminologies such as guest OS, host, privileged instructions, etc. So, in the forthcoming slides, we will give the explanation for all such things. When you consider the virtual machine monitor, you can define in this way. It is a virtualization system that partitions a single physical machine into multiple virtual machines. So, we are using the terminologies host and guest. The machine and or software on which the virtual machine monitor is implemented is known as host. The physical machine is host machine. The actual software or OS installed over the physical machine is known as host OS. Once again I repeat it, the physical machine is called as host machine. The operating system installed over the physical machine is called as host OS. Second one is guest, the OS which executes under the control of the virtual machine monitor. After creating virtual machine over the physical machine, again in that machine you have to install the operating system before you make use of it. So, the operating system which is installed in the virtual machine is known as guest OS or guest operating system. So, you are having the host operating system which is installed in the physical machine, guest operating system which is installed in the virtual machine. So, these terminologies we must be familiar. Then this is the definition of the virtualizing software. Say you are having the actual hardware machine, then you are having the virtual machine monitor, that is VMM, that is called as virtualizing software, and above that it is possible to create your OS and application. Now, whenever you get the new virtual machine, again this will become the virtual machine, and above that you can install the OS and other applications also. So, this is the physical machine on which you are installing the VMM and you can create the guest OS. So, by combining host and VM, again it is a virtual machine. It is possible to create another virtual machine over this also. Now, virtualizing software can translate the instruction set architecture used by one hardware platform to another, forming a virtual machine capable of executing the software developed for a different set of hardware. The virtualizing software will often be referred to as the virtual machine monitor. So, we have defined the basic definitions such as host, guest and VMM. Let us have a short break now. Welcome back after the break. Now, we are going to just discuss about what is a virtual machine. It is capable of virtualizing a whole set of resources including processors, memory, storage and peripherals. The three properties of interest in case of virtual machines are equivalence, control and efficiency. This is according to the paper written by Popek and Goldberg in 1974. It is worth reading paper. It is available on the internet open. So, please you go through the paper to understand the actual concepts of virtual machine. The meaning of equivalence is like this: program run on the virtual machine should exhibit behavior identical to running on the equivalent machine directly. Suppose if you are running one job in the physical machine and you are running another job on the virtual machine which is created over the physical machine, both should have the identical behavior. That is the meaning of equivalence. Second one is control. The virtual machine manager must be in control of the virtualized resources. So, you are having the virtual machine monitor or manager that should have the total control of the virtual machine, as the particular physical machine is also controlled by OS and other manager. So, the control is by VMM in case of virtual machines. Then efficiency, majority of the instructions must be executed without intervention of the virtual machine manager. Actually, the VMM will be intercepting many of the instructions. It is important to have majority of the instructions of the physical machine should be executed without the intervention of the virtual machine manager. Only a few instructions should be intercepted or it should be managed. That is called as efficiency. So, you should have the equivalence performance, it should have the total control over the virtual machines by the virtual machine manager, and also you should have the efficiency by having almost all the instructions being executed. Now, this is the paper formal requirements for virtualizable third generation architecture written by Gerald Popek and Robert Goldberg. So, you please download this paper, and from that paper only all this efficiency, resource control, equivalence, everything we have discussed, and they have given this virtual machine, that is you are having the virtual machine monitor over the hardware and you are able to create an efficient isolated duplicate of the real machine. So, you can read this paper, and based on the paper what are the important concepts we are doing. See here, virtual machine monitor he has defined it is an efficient isolated duplicate of the real machine, and essential characteristics to be considered by a virtual machine monitor are equivalence, performance and resource control. See, software on the virtual machine monitor executes identically to its execution on hardware barring timing effects, that is called as equivalence. Then the performance, non-privileged instructions can be executed directly by the real processor with no software intervention by the VMM. Then resource control, the virtual machine monitor must have complete control of the virtualized resources. So, these 3 points they have insisted, and see this is equivalent to running on VMM is equivalent to running directly on the physical hardware. Performance on VMM should be equivalent to performance on the hardware. Now, the different instruction types they have mentioned. The first one is privileged instruction. What is the meaning of privileged instruction? The instructions that generate a trap when executed in any but most privileged level, that is called as privileged instruction. See, for example, LIDT, load interrupt descriptor table, is an example of privileged instruction. The next one is sensitive instructions, instructions whose behavior depends on the current privilege level. So, the example is a pop-up instruction. See, in the user mode, the interrupt enable bit of the flag register is not overwritten. In system mode, the value is blindly copied. So, the sensitive instructions will behave depending upon the mode of the actual execution. So, privileged instructions and sensitive instructions, these two types of instructions are available in the system whenever you go for machine virtualization. You should think of the various options by the privileged and unprivileged instructions. The regular applications use unprivileged instructions and these instructions are easier to virtualize. And if regular applications execute privileged instructions, they always trap. Then virtual machine catches the trap and emulates the instruction. So, this is the actual principle we are using. To understand the concept, we are seeing some more details about the actual instructions and how the interrupt is taking place. All those things are explained in the subsequent slides. Say for example, if you take the pop-up instruction, here this instruction will behave differently depending upon the execution mode. If you consider the user mode, it changes the ALU flags. If you run in the kernel mode, it changes both ALU as well as system flags. So, based on the execution mode, the actual instruction is behaving differently. That is why it is called as sensitive instruction. Based on the execution mode, it is changing its actual operation. So, this instruction is known as sensitive instruction. It does not generate any trap in the user mode and acting as a non-privileged instruction in the user mode. So, that is the problem we are facing in such instruction. So, let us see how the trap and emulate operation is taking place. Let us consider the OS is in the privileged mode and user process is always in the user mode. Now, the user process is here, kernel, that operating system's privileged mode, and you are having the physical machine. When you just send a system call or some exception, it is sent to the kernel. Now, the kernel will interpret the meaning of that particular call and all, then in turn it will contact the physical machine. Suppose if you are having non-privileged, then directly you can interact the physical machine also, because it is not going to affect anything. Suppose if you are directly invoking the privileged instruction, what happens? It is trapped and it is sent back to the kernel. If there is an exception handler available, then it is going to act the actual operations to be performed. So, if you consider this one, you are having the system calls to be sent through the kernel of the operating system to invoke the physical machine. Non-privileged instruction, it does not have any problem. Whenever you have the privileged instruction, it is trapped, and if the exception handlers are available, then kernel will automatically interpret and in turn it will invoke the physical machine's activity. So, this is the concept of trap and emulate. Now, let us consider the actual thing using our virtualization concept. Here you are having one more layer introduced in between the kernel as well as physical machine. We are having the virtual machine monitor, VMM is here. So, how does it operate? Whenever a privileged instruction is sent from the kernel, again it is trapped, because the kernel is considered to be the user mode above the virtual machine monitor. This is the guest OS which is sending the thing to its OS. So, whenever it is sending the privileged instruction, the physical machine cannot interpret it, that is why it is trapped. Then once it is trapped, it is having the trap handler. So, the virtual machine monitor is having the trap handler and it is managing. So, this is the way the virtual machine monitor is acting in the privileged mode, and the actual application which you are running in the virtual machine is interpreted in this way. So, this is the working principle, and we know there is a number of protection rings available. So, this is Intel IA32 protection rings. We are having the level 0 to level 3. Level 0 is having the highest privilege and level 3 is having the lowest privilege. In level 0, we are having the operating system kernel. The kernel is available in the level 0, and the operating system services as well as device drivers etc., they will be available in level 1 and level 2. Applications are available in level 3. So, in this way the privileges are given. Now, how the virtualization through the ring compression is taking place? Here we are having 0 to 3. the virtual machine monitor is running at ring 0, that is the actual thing. Then kernel is running at ring 1 and it requires the CPU to be virtualizable, then only it is possible to create the virtual machine. That is also another important condition which we have to understand. Now, when you consider x86 architecture, can x86 trap and emulate? No. The reason is it is having the lack of traps when privileged instructions run at user level, since the dual purpose instructions do not trap. Dual purpose instructions are nothing but sensitive instructions. So, you are having the OS, then other services in between, OS services as well as device drivers, then application at the outermost layer. So, it is not possible to have this type of trap and emulation. So, how it is overcome? Intel architecture does not support the trapping of privileged instructions. So, they are following two approaches. One is using binary translation. So, it scans the instruction stream and replaces the privileged instructions with something the VM can intercept. So, that is called as VMware approach. Otherwise, you can make use of the following concept, that is, do not use non-virtualizable instructions at all, that is the Zen approach. So, by using this method, the limitation is also overcome. So, in the virtualization of the x86 hardware, you are having the actual 17 unprivileged instructions that are sensitive to the machine state. So, they are doing it by using para virtualization or full virtualization. That para virtualization is called as modified device drivers in the kernel. Kernel itself is getting modified in the para virtualization, and full virtualization means you are having the Intel VT X technology and AMD V Pacifica model. So, that you are using the HVM mode and you are able to make use of the full virtualization also. So, in the para virtualization you modify the kernel, in full virtualization it is kept above the actual operating system and this VMM is placed over the OS and it is not changing the kernel of this one. It is having the provision to give the various instructions as per the instructions received from the VMM. So, we are having the Intel virtual technology, Intel VT means virtual technology, as well as AMD Optron, all those things are having these things, and certain privileged instructions are intercepted as the virtual machine exits to the virtual machine monitor, and exceptions, faults and external interrupts are intercepted as the VM exits, and also virtualized exceptions, faults are injected as VM entries. So, these are the architectural support given and it is possible to complete the virtualization. Now, we should know what are the theorems given for the purpose of this virtualization. This is theorem 1 given by Popek and Goldberg. According to this, for any conventional third generation computer, a VMM may be constructed if the set of sensitive instructions for that computer is a subset of the set of privileged instruction. What is the meaning of it? See, ISA is virtualizable in case if you are having SA is subset of PI, SA is sensitive instruction, PI is the privileged instruction, whereas if the SA is not subset of the PI, it is not virtualizable. So, we are having the first theorem which gives the condition for virtualizable ISA. So, we have discussed about the various concepts in the virtualization by having the trap and emulate concept of privileged instructions as well as sensitive instructions, and it is essential to answer some of the questions. What is privileged instruction? What is sensitive instruction? What are the conditions for virtualization? What are the limitations of Intel x86 architecture? What are the various protection rings available in Intel architecture? Give the first theorem of Popek and Goldberg. So, once if you are able to find out the answer to these questions, you will be understanding the basic concepts of virtualization. Thank you.